Hi, welcome all of you in this video where we are going to talk about KSQL. This is the first video of the course and we will start with introduction and talk more about the use cases and design of KSQL. In this course, we will talk about the fundamentals of KSQL. We will talk about streams, tables, and how to generate data with the help of KSQL DataGen tool. Then we will move towards some advanced operations including windowing, aggregations, joins, and geospatial operations. We will also take a look as how we can support different types of data ranging from CSV to JSON to Avro in our KSQL operations. Towards the end of this course, we will talk about extending the KSQL with the help of user-defined functions and user-defined aggregate functions called as UDF and UDAF in short. And then we will end up with some production tips, how we can move our KSQL to a production environment. We will talk about scaling out, we'll talk about using headless configurations and a lot more. Before beginning, let me quickly introduce myself. I am Amit Ranjan. I'm working as a data engineer and for last many years I have been involved in designing and implementing solutions to the big data problems to process and analyze large amount of data in the real time. I have also been very active in mentoring, mostly through online platforms. And here is my LinkedIn profile. In case you are interested, we may connect. Now we have understood what we are going to cover. Let us understand who should take this course and what are the prerequisites before taking this course. If you are a developer who want to learn and write the KSQL applications for the very first time, or if you are an architect who wants to understand how KSQL will fit into the solution design, then this course is very apt for you. Not only that, anyone who wants to learn more about KSQL is welcome in this course. Since KSQL is built on top of Kafka, a fundamental understanding of Kafka is the chief prerequisite for this course. If you are aware of Kafka streams, then it will be a good plus, but a knowledge of Kafka stream is mostly desirable but not mandatory. The very first thing, what exactly is Kafka? Kafka is essentially a distributed publish subscribe model. But that's not the only use case it has. Kafka fits into a variety of use cases. Kafka acts like a buffer between your producers and consumers. So you could have data coming from a mobile application or different sensors or different other applications or databases, and then there could be different consumers who are subscribed to specific topics which contain the data. So in this case, Kafka acts like a buffer or acts like a publish subscribe model. Essentially, Apache Kafka is a distributed event streaming platform which is capable of handling trillions of events a day. This is the definition supported by Confluent Kafka. Initially, it was conceived as a messaging queue and it is based on the abstraction of a distributed commit log. So, why is Kafka so popular? The first thing is it makes the producer and consumer decoupled, so it's very easy to add a new application, whether it be a producing application or it be a consuming application. It is very popular to be used as a buffer so as to support variable ingestion rates. On the right side, you could see an image taken from our production situation, where you see the message ingestion rate to a Kafka topic varies from 500 messages or even less than that a second to approximately 45,000 messages per second. So you see there is a wide variation in the input rate of the message, and Kafka has the capacity to act as a buffer in case of that high fluctuation of incoming messages. And Kafka also supports a variety of use cases like a distributed queue. It supports the use case of log compaction, and the very important thing is Kafka is the skeleton of a real-time streaming. If you talk about any real-time streaming platform, Kafka will be an integral part of that design. So Kafka has a lots of different and variety of use cases, but still Kafka is neither a storage solution nor it is a stream processing solution. Well, that was never the design, that was never the intention of Kafka. Kafka maintains a log file which contains the actual data. So every data has associated offset, then it will have a key and it will have a value. So if this is the log file, by log file I mean the file where Kafka stores its data. If a new message arrives, that will be added to the end of the file, which is called the append operation. You can see the append operation is very fast because it is added to the end. It takes constant time, but this is not the storage solution, as you would expect in any kind of a database where you have some kind of index to efficiently scan a particular key or a particular value. This is not the case. Also, many a times you would like to specify some retention period in Kafka. In most of the solutions, you would not keep your data forever. If you have the space, you can keep it for a longer time. But Kafka is not intended to keep a data forever. Most of the time you would like to use HDFS or S3 or some other database storage to efficiently retrieve your data as well as store your data for a longer time. The second thing is Kafka was never intended to be used as a stream processing solution. By this I mean Kafka is just a storage. It will just store your data. It will do nothing with your data. It will not try to extract any meaning out of your data. It will not try to do any processing out of your data. I would like to give one example. Suppose this is your Kafka cluster, and inside this Kafka cluster you have one Kafka server, or you can say a broker, and then you have another Kafka broker. So you have broker B1 and you have broker B2, and you can have lots of other brokers as well. Let us talk about some sensor data. Assuming we are getting some temperature data, and at some time the temperature is 30 degrees Celsius. After few seconds it becomes 31 degrees Celsius. After few seconds it becomes 32, and so on. Say at time 00 it was 30, at time 0010 it becomes 40. So what do you infer from this particular trend is that the temperature is increasing at a good rate. For some situations this could trigger an alarm that the temperature is increasing at some undesirable rate. What will happen is, depending upon the key and value, these topics will keep on storing the data. There could be some data in this partition, there could be some data in the other partition. So all the temperature data you can see will be stored across different partitions. But the point is, Kafka will not care whether the temperature data is increasing or not. In other sense, Kafka does not worry about what data you are pushing to it. All it will do is push it for you in a reliable and a scalable manner. You need to have some other kind of processing. So you have to process the data from all different partitions of a topic, and then this is where your business logic will be placed. In this case, the business logic can be to see what is the rate of increase of the temperature. So you will be constantly reading the data present in Kafka, applying the business logic, and then trying to see whether you should trigger an alarm or not. So this process is outside Kafka. So you have one Kafka cluster, and then you have a processing cluster. This processing cluster can be Apache Spark, or it could be some other stream processing frameworks like Flink. You have a Storm, and then you have lots more. But the point is, each of these, which are distributed and which are extremely good in many use cases, require a different cluster altogether than Kafka. So far, you would have understood that Kafka is neither a storage solution nor a stream processing solution. For both of these solutions, you have to rely on some other tools, some other frameworks. KSQL is a solution to the second concern. That is, it is a solution to the stream processing capabilities. But before we talk about KSQL, it is very important to talk about Kafka Streams. What is Kafka Stream? Kafka Streams is a client library around Apache Kafka, which adds the stream processing capability. So you will be having a Kafka topic. Say you have a Kafka topic A and a Kafka topic B. You read the data of Kafka A using certain library, you process the data, and whatever is your result, you push it to Kafka topic B. This particular processing can be done using Kafka Streams. So Kafka Streams is that library which helps in building the stream processing applications and microservices. This adds the stream processing capability inside the Kafka cluster, because like other data processing frameworks like Flink or Spark, you need not to have a separate cluster. You can run the Kafka Streams on the periphery of your Kafka cluster altogether, and it has very strong support for Apache Kafka, including the exactly once guarantee. Some of the important features of Kafka Streams include it is highly scalable, it's very elastic and fault tolerant as well. You can use virtual machines, or you can use Docker containers, or you can use bare metal machines to run and deploy it. Depending upon the use cases, it can be used for small to medium to large scale of data. It integrates very well with the Kafka security, and you can write a Kafka Streams application using Java or a Scala. And finally, you need not to have a separate processing cluster. While Kafka Streams is a very revolutionary feature present in the Kafka cluster. It has certain limitations. The first thing is it uses topologies and it uses language DSLs and programming APIs to achieve the result. And here is what a learning curve is involved. Since it uses programming languages, and as a user, as a developer, you have to consider the internals of how you have to write your application. You have to consider the internals about handling the corner cases. Chances are your application may break sometimes when the boundary conditions or the corner cases are encountered. And the people who are coming from SQL background find it difficult to harness the full functionality of Kafka streams. The second thing is there is lots of boilerplate code. Whenever you would like to develop a Kafka stream application, there are certain imports, certain constructs, certain constructors which are repeated all the time. So even for a simple transformation, your code will be quite long, maybe exceeding 10 to 20 lines of code, even for a single simple transformation. So far we have seen that Kafka Streams is a very useful and a very powerful library, but its utilization is limited because of the use of programming languages and writing lots of boilerplate codes. KSQL helps us to reduce that complexity in using the Kafka streams. So let's talk about KSQL now. KSQL, first of all, it is the streaming SQL engine for Kafka. Just like you write a SQL in RDBMS, you say select star from this particular table, or you say select this column from this table, and you apply a where clause to filter out the records. And then you can also use joins on certain condition with some other table. You can do all of these using KSQL. So KSQL internally uses Kafka streams, but it gives you the access to Kafka streams through a SQL interface. So just by writing one line of a SQL query, you can achieve the same result as by writing 10 to 20 lines of a Kafka streams Java application. It provides an interactive SQL interface, and again it has all the features of Kafka streams like scalability, elasticity, fault tolerance, and the real-time behavior. KSQL supports wide range of streaming operations which are listed over here. It could be data filtering or transformation or join. We will also see it also supports the window operations and sessionization as well as aggregations. Let's talk about the use cases of KSQL. The use cases of KSQL and Kafka streams are the same. It's just that KSQL is an elegant and very, very comfortable way to talk to Kafka using Kafka streams. The first thing is streaming ETL. If you would like to have a real-time application, a real-time pipeline, and this real-time pipeline is very important, whether it be a stock market, finance operation, or it could be a logistic operation. I work for a company which provides ride-hailing services in real time. So for a ride-hailing platform, you would also like to capture the metrics and monitor the performance KPIs in real time. So for all the streaming ETLs where Kafka is the backend, KSQL provides the access to Kafka data in a very interactive and easy manner. The second point is related to the first, which is real-time monitoring. The third use case is data exploration. where you have data present in your Kafka topic and you would like to see it. Data in a Kafka topic can be in a variety of format, like it can be CSV, it could be Avro. So depending upon the type of data, you can access the data of Kafka using a Kafka consumer. The simplest consumer is a console consumer. You specify that Kafka Avro console consumer or Kafka console consumer, and then you give the details like this is the Zookeeper, or this is the Bootstrap server, this is the topic, and so on and so forth. And then you start consuming the messages. With KSQL, you just type print this particular topic and it will give all the messages of that particular topic. So it's as easy as that. You need not to write lots of helping syntax around the console consumer. So in order to navigate through the data of Kafka, KSQL is a very comfortable option. The other important use case is anomaly detection. Suppose someone has lost his credit card, and this credit card is used by some other person who does not know the PIN of this card, and he is trying to swipe the card at certain shop, and we observe that there have been, say, 5 illegal attempts at entering the PIN code in the last 10 seconds. Well, this is some kind of odd behavior. This is an anomaly. Whether it is a data coming from some sensor or some other application, there could be different anomalies. And if you have the real-time access to the data, and if you can do a real-time processing, these anomalies can be detected as early as possible. And KSQL can help you achieve that anomaly detection. Then the other use case is about personalization. One example is, suppose if a user visits to your website and does some kind of activity. The activity involves going to a particular page, staying there for some time, scrolling through different sections of the page, and then logging out. So what you do is, if you maintain a session of the user and you capture all the activity of the user, in the real time, you can just process your machine learning models or your AI models to understand what could be the likes and dislikes of the user based on the activity. And in the real time, you can send an email or some kind of notification to the user that based on his activity, he would like to see some more posts or some other products. So it's a kind of recommendation which is personalized and can happen in real time. And KSQL can perform a very vital role as the processing engine of this pipeline. Then you can process your sensor data and IoT data in real time. Just a few minutes back, we discussed about the temperature use case. Like if you have temperature coming from some sensor data and it is always going on increasing, and you can detect like, yes, this is some kind of behavior which needs immediate consideration, or this is a behavior which should trigger an alarm. You can do that. And yes, you can have the full view of a customer if you can analyze the data coming as early as possible from different sources. We will talk about the components of KSQL now. In the back, there is a Kafka cluster from where data is read or data is written, or both. And then we have KSQL servers. Each KSQL server has one KSQL engine, This engine executes the KSQL statements. A KSQL statement looks very similar to a SQL statement, like select this column from this particular topic. Under the hood, this engine builds the Kafka Stream application. We can interact to the KSQL server through the REST API, and our clients can be a KSQL UI or a KSQL CLI. KSQL UI currently is not present in the open source version of Confluent. KSQL CLI is there, and with the KSQL CLI we can just interactively type our queries, our SQL statements, and using REST API it connects to the KSQL server, where the engine will receive the KSQL statement and run it for us and give back the result if that query or if that statement returns something. So this was for the introduction of KSQL. In this video we talked about why we would like to learn KSQL. We talked about Kafka, what is Kafka and what Kafka is not. We also talked about K-streams, what functions it adds to the processing, and what are the difficulties with K-streams. Then we moved ahead and talked about KSQL, how it makes life easy to do processing on top of Kafka data. And then we also talked about some of the use cases where KSQL is a very good fit. We ended our discussion by taking a look at the components of KSQL. In the next videos, we will learn the concepts of streams and tables in KSQL, a demonstration, and in further videos, we will talk about setting up KSQL, the basics, extending KSQL, and moving KSQL in production. So before the next session, there are certain softwares you will need to install on your machine. There are 3 of them. One is a virtual machine, and then there is a virtual box, and then we have a MobiXterm client. All the details and descriptions are placed in that Google Drive link. So see you in the next video.